question addresses whether the 100% assembly rating of electrical conductors and overcurrent protection has any connection to 90° C equipment or conductor temperature provisions. Specifically, it asks if a 100% rated assembly can only be used with 90° C rated enclosures, terminations, and conductors. The answer is no. The assembly rating is entirely separate from any allowance for conductor or equipment temperature. This means that the ability of an assembly to operate at 100% of its rating is independent of the temperature ratings of its individual components such as conductors, enclosures, and terminations. To further illustrate this point, consider a 100% rated panel board assembly. This assembly can be applied in two ways. Firstly, it can be used with 75° C conductors, conduit, and overcurrent devices that are supplied by the assembly manufacturer. Secondly, it can be used with 75° C field-installed conductors, conduit, and overcurrent devices that meet the requirements of 110.14 C of the National Electrical Code, NEC. In either of these scenarios, the conductors, terminations, and the panel board itself are all rated for 75° C operation. This is in accordance with the provisions outlined in 210.19 Aeon and 210.19 Atwo of the NEC. Let's break down what this means in more detail. The 100% rating refers to the capability of the assembly to handle continuous loads equal to its rated capacity without exceeding its design limits. This is particularly relevant in situations where electrical loads are expected to operate continuously for extended periods, typically 3 hours or more. Without the 100% rating, standard electrical codes often require that conductors and overcurrent protection devices be sized at 125% of the continuous load to prevent overheating and potential failures. However, with the 100% rated assembly, this upsizing may not be necessary, provided that the assembly is specifically listed and labeled for such operation. Now let's address the temperature ratings of the components. Conductors, terminations, and equipment enclosures all have temperature ratings that specify the maximum temperature they can withstand under normal operating conditions. These temperature ratings are crucial for ensuring the safety and reliability of the electrical system. The NEC provides guidelines for selecting conductors and equipment with appropriate temperature ratings based on the application and the ambient conditions. In the example provided, the conductors, terminations, and panel board are all rated for 75° C operation. This means that they are designed to operate safely and effectively at temperatures up to 75° C. It is important to note that the 75° C rating does not preclude the use of the 100% rated assembly. The key is that the assembly as a whole is listed and labeled for 100% operation, and the individual components meet the temperature requirements specified by the NEC. The reference to 110.14 C further clarifies the requirements for terminations. This section of the NEC specifies the temperature limitations for conductors and equipment terminations. It essentially dictates that the terminations must be suitable for the temperature rating of the conductors being used. In other words, if you are using 75° C rated conductors, the terminations must also be rated for 75° C or higher. This ensures that the terminations do not become a weak link in the system and contribute to overheating or failure. The specific provisions of 210.19 Aeon and 210.19 Atwo relate to the ampacity of conductors. Ampacity refers to the current carrying capacity of a conductor, and it is directly related to the conductor's temperature rating. The NEC provides tables that list the ampacities of different types of conductors based on their size, insulation type, and ambient temperature. These tables take into account the heat generated by the current flowing through the conductor and the ability of the conductor to dissipate that heat without exceeding its temperature rating. 210.19 Aeon generally covers branch circuit conductors, while 210.19 Atwo covers feeder conductors. Both sections emphasize the importance of selecting conductors with adequate ampacity for the intended load and ensuring that the conductor's temperature rating is compatible with the terminations and equipment to which it is connected. In summary, The 100% assembly rating allows for the application of conductors and overcurrent protection devices at their full rated capacity for continuous loads, provided that the assembly is listed and labeled for such operation. This rating is independent of the temperature ratings of the individual components. You can use 75°C rated conductors, terminations, and equipment in a 100% rated assembly as long as they meet the requirements of 110.14C and the ampacity requirements of 210.19 AON and 210.19 ATWO. The critical factor is ensuring that all components are properly rated for the intended application and that the system as a whole is designed and installed in accordance with the NEC. To provide a more detailed example, let's consider a scenario involving a 100 amp 100% rated panel board assembly used in a commercial building. This panel board is supplying power to a continuous load, such as lighting or HVAC equipment, that is expected to operate for more than 3 hours at a time. According to standard NEC practice, without the 100% rating, the conductors and overcurrent protection devices would need to be sized at 125% of the continuous load, which would require a 125 amp rated circuit. However, because the panel board assembly is listed for 100% operation, the conductors and overcurrent protection devices can be sized at 100 amps, provided that all other requirements are met. This can result in cost savings and reduced space requirements, as smaller conductors and overcurrent protection devices can be used. Now let's assume that the panel board assembly is supplied with 75°C rated conductors, conduit, and overcurrent devices by the manufacturer. This means that all of these components are designed to operate safely at temperatures up to 75°C. The installer verifies that the terminations on the panel board and the connected equipment are also rated for 75°C or higher, in accordance with 110.14C. Furthermore, the installer ensures that the conductors have sufficient ampacity for the 100 amp load based on the ampacity tables in the NEC, taking into account the conductor size, insulation type, and ambient temperature. The installer also complies with the requirements of 210.19 AON and 210.19 ATWO, ensuring that the branch circuit and feeder conductors are properly sized and protected. In this scenario, the 100% rated panel board assembly can be used safely and effectively with the 75°C rated components, as long as all applicable requirements of the NEC are met. The 100% rating allows for the full rated capacity of the assembly to be utilized for continuous loads, while the temperature ratings of the components ensure that they operate within their design limits. It is important to note that the use of a 100% rated assembly does not eliminate the need for careful planning and installation. The installer must still perform load calculations, select conductors and overcurrent protection devices with appropriate ampacity and temperature ratings, and ensure that all connections are properly made. Additionally, the installer must be aware of any specific instructions or requirements provided by the manufacturer of the 100% rated assembly. These instructions may include limitations on the types of loads that can be connected, restrictions on the ambient temperature, or other factors that could affect the performance of the assembly. In conclusion, the 100% assembly rating is a valuable tool for optimizing electrical system design and reducing costs, but it must be used in conjunction with a thorough understanding of the NEC and the specific requirements of the equipment being installed. The temperature ratings of the components are a critical consideration, and they must be carefully selected to ensure the safety and reliability of the system. Furthermore, it is essential to consult with a qualified electrical engineer or inspector to ensure that all applicable codes and standards are met. To elaborate further, let's explore the practical implications of using 75°C rated conductors in a 100% rated assembly. The NEC specifies different ampacity ratings for conductors based on their temperature rating. For example, a copper conductor with a 75°C insulation rating will have a lower ampacity than a similar conductor with a 90°C insulation rating. This is because the 75°C conductor is designed to operate at a lower maximum temperature, and therefore it cannot carry as much current without overheating. When using 75°C rated conductors in a 100% rated assembly, it is crucial to select conductors with sufficient ampacity for the intended load, taking into account the low temperature rating. This may require using larger conductors than would be necessary with 90°C rated conductors. However, the advantage of using the 100% rated assembly is that the conductors can still be sized at 100% of the continuous load rather than 125%, which can offset the cost of using larger conductors. Another important consideration is the ambient temperature. The ampacity ratings of conductors are based on a specific ambient temperature, typically 30°C. If the ambient temperature is higher than this, the ampacity of the conductor must be derated to account for the increased heat. The NEC provides derating factors for different types of conductors and ambient temperatures. When using 75°C rated conductors in a 100% rated assembly, it is essential to consider the ambient temperature and apply any necessary derating factors. This is particularly important in hot environments such as attics or outdoor installations. In addition to the conductor ampacity and ambient temperature, it is also important to consider the voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or fail, and it can also reduce the efficiency of the electrical system. The NEC recommends limiting the voltage drop in branch circuits to 3% and in feeders to 5%. When using 75°C rated conductors in a 100% rated assembly, it is important to calculate the voltage drop and ensure that it is within acceptable limits. This may require using larger conductors or shortening the length of the circuit. Furthermore, the type of load being supplied can also impact the selection of conductors and overcurrent protection devices. Some loads, such as motors, have high inrush currents when they start. These inrush currents can cause overcurrent protection devices to trip, even if the load is not actually overloaded. To prevent nuisance tripping, it may be necessary to use overcurrent protection devices with a higher interrupting rating or to use time delay fuses. When using 75°C rated conductors in a 100% rated assembly, it is important to consider the type of load being supplied and select overcurrent protection devices that are appropriate for the application. In addition to the technical considerations, it is also important to consider the cost. 75°C rated conductors are typically less expensive than 90°C rated conductors. However, the cost savings may be offset by the need to use larger conductors or to install additional overcurrent protection. When selecting conductors and overcurrent protection devices for a 100% rated assembly, it is important to consider the total cost of ownership, including the initial cost, the operating cost, and the maintenance cost. Finally, it is essential to comply with all applicable codes and standards. The NEC provides detailed requirements for the installation of electrical systems, and it is important to follow these requirements carefully to ensure the safety and reliability of the system. In addition, local codes and standards may impose additional requirements. When installing a 100% rated assembly, it is important to consult with a qualified electrical engineer or inspector to ensure that all applicable codes and standards are met. To further clarify the relationship between the 100% assembly rating and the temperature rating of conductors, let's consider some specific examples from the NEC. The NEC provides ampacity tables for conductors in Article 310. These tables list the allowable ampacities for different types of conductors based on their size, insulation type, and temperature rating. For example, Table 310.15b16 provides ampacity ratings for conductors with various insulation types, including 60°C, 75°C, and 90°C. When using a 100% rated assembly, it is important to select conductors with an ampacity rating that is sufficient for the continuous load, taking into account the temperature rating of the conductor and any applicable derating factors. For example, if you are using a 100% rated panel board assembly and you are using 75°C rated conductors, you would need to select conductors with an ampacity of at least 100 amps at 75 degrees C. According to Table 310.15b16, a number 3 AWG copper conductor with a 75 degrees C insulation rating has an ampacity of 100 amps. Therefore, you could use a number 3 AWG copper conductor with a 75 degrees C insulation rating for this application. However, if the ambient temperature is higher than 30 degrees C, you would need to dare the ampacity of the conductor. For example, if the ambient temperature is 40 degrees C, you would need to dare the ampacity of the conductor by a factor of 0.88 according to Table 310.15b2. This means that the allowable ampacity of the number 3 AWG copper conductor would be reduced to 88 amps. In this case, you would need to use a larger conductor, such as a number 2 AWG copper conductor which has an ampacity of 115 amps at 75 degrees C. After derating for the ambient temperature, the number 2 AWG copper conductor would have an allowable ampacity of 101.2 amps, which is sufficient for the 100 amp load. It is also important to consider the termination temperature rating when selecting conductors for a 100% rated assembly. The NEC requires that conductors be terminated in a manner that is suitable for their temperature rating. This means that the terminals on the equipment and the overcurrent protection devices must be rated for the same temperature as the conductors. For example, if you are using 75 degrees C rated conductors, you must use terminals that are rated for 75 degrees C or higher. In many cases, equipment and overcurrent protection devices are marked with a temperature rating. This marking indicates the maximum temperature that the equipment or device is designed to operate at. When selecting equipment and overcurrent protection devices for a 100% rated assembly, it is important to ensure that the temperature rating of the equipment and devices is compatible with the temperature rating of the conductors. In summary, the 100% assembly rating allows for the use of conductors and overcurrent protection devices at their full rated capacity for continuous loads, but it does not eliminate the need to consider the temperature ratings of the components. It is essential to select conductors with sufficient ampacity for the intended load, taking into account the temperature rating of the conductor, the ambient temperature, and any applicable derating factors. It is also important to ensure that the terminals on the equipment and the overcurrent protection devices are rated for the same temperature as the conductors. By following these guidelines, you can safely and effectively use a 100% rated assembly while complying with the requirements of the NEC.